Okay, this is 7th grade 7.1.6 and it's titled How Can I Solve Complicated Equations? So last week we started with getting rid of fractional coefficients and now we're getting into more complicated equations with fractional coefficients. Remember, a coefficient is a number that's attached to a variable. So this would be the coefficient here, 2 would be the coefficient of this x. If it's a fractional coefficient, this whole thing, if you have 2/3 x, because that's pretty much what that means, that's a fractional coefficient. There's a fraction, there's a fraction. So we are going to try and solve these problems with shortcuts on how to get rid of the fractions to make them easier to solve. Okay, and Bailey's here for support. Okay, so it says Sherry, I think that says Sherry or Cherry. Sherry volunteers over the summer in a vet clinic. Bailey, don't move my chair. The doctor has told Sherry to determine the correct dose of medicine to give to the cat, Sweetie, who weighs 9.5 pounds. The dosage in milliliters for a 9.5 pound cat is given by X in the formula. So here's the formula for the dosage for the medicine. It says Sherry had never solved such a complicated equation before. She thought about how Janice visualized algebra tiles in the problem 752 in the last lesson and wondered if that could help. So remember, Janice was solving her diagram with fractional coefficients by multiplying everything by a certain number to make whole number tiles. So it says help Sherry rewrite the equation with integers, determine the correct dose of medicine to give to Sweetie. So really that's telling us to solve for x. So here's the diagram. I drew it on my whiteboard and it's on the book. So we've got 2/3 x, so that corresponds with that term, plus 4/3. So you'll notice that this is two squares. They're each divided into thirds, and then I shaded in 4 of those thirds. So that's plus 4/3. Here's our equal sign. And then we have 10/3 represented by these little pictures of 1, 2, 3, 4 squares divided into thirds. Shade in 10 of those thirds. So this is the original problem. Now we need to help her rewrite it with integers. Remember, an integer is a whole number that is negative or positive. It can't be a fraction. So we got to get rid of these fractions. And I'm going to use a different color. And I'm going to use the strategy that Janice used in the last problem. So she looked at the denominators of her fractions, and she thought, well, if I multiplied by my denominators, I'm going to end up with a whole number on the top. So that's what I'm going to do. Actually, I'm going to do it. So let's multiply this 2/3 x by 3. So we're going to draw 2 more of that same one. Oop, nope, I'm going to do it one thing at a time. And then the 4/3, I'm going to draw another one of those because we're multiplying everything by 3. Okay, so now I have 2 sets. Let's do one more set. Shade in 2, and that's the whole x, and then make 1, 2, 1, 2, shade in 4. All right, so now if I count up my total thirds that I'm left with here, with my bars, I'm left with 1, 2, 3, 4, 5, 6. So I'm left with 6 thirds. And you keep that x there. The x doesn't go anywhere. It stays with it. Okay, so I'm just writing what this transforms to. Okay, so we've accounted for those. Now let's count how many thirds we have with our 4/3 term. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 thirds there. Okay, now I'm done with that side. So now if I come to this side, I'm going to have to draw a lot because I'm going to want to multiply this 10/3 by 3. So I'm going to draw another set of that. 1, 2, 1, 2, 1, 2, shade in 10 of them. So 3, 6, 9, 10. Okay, so that's 2 sets. We need one more set. 1, 2, 3, 4, shade in 10. All right, now I can count up the total amount I've shaded here on this right side. So I've done 3, 6, 9, 10, which this would be another 10, so that's 20, another 10, that's 30. So that becomes 30/3. Now it looks like I still have fractions, but we can simplify these fractions so that they're whole numbers. So let's do that. I'm going to do it down here. So this 6 divided by 3 gives us 2. Keep the x isn't going anywhere yet. Plus 12 divided by 3, 4, equals 30 divided by 3, which is 10. So now I've got a nice, easy equation to work with to solve for x. And so I'm going to do that. And to solve for x, we want x all by itself on one side. So if I want to do that, I need to get rid of this positive 4. To make positive 4 0, we're going to minus a 4 from both sides because you have to balance the equation no matter what. So that becomes 0. This still is 2x equals 6. And then we divide both sides by 2. X would equal 3. So that's going to cancel to 1. So we've figured out from that complicated equation that x equals 3. And I think that's all that they wanted us to do for 763. So that was the first problem, 763. Now we're going to go on to 64, which gives us a new equation to work with. Okay. 764 says, examine the equation below, and it gives us, wow, it's really small, x over 4 minus 5, 6 equals 7. Part A is telling us to multiply each term by 4. If you're wondering what a term is everything that's separated by a subtraction symbol or addition symbol or an equation sign. So this is, how many terms do we have here? We have 1 term, 2 term, 3 terms. 1, 2, 3. So it wants us to multiply each one by 4. So here's how I do it. I put a bracket around the entire equation. I'm going to move this 764. I put a bracket around the whole equation to show that I'm going to multiply everything inside the brackets by one number. And I'm going to multiply everything by 4. And I put it over 1 just because everything's kind of a fraction right now, except that 7. Okay, so if we multiply that 4 to each term inside the equation, that should be to 7. Let's find out what happens. So I'm left with 4 over 1 times x over 4, which is, if we multiply across, 4x over 4. And that can be even simplified more because we know 4 divided by 4 is just 1. So that's just going to be x. So this whole term just becomes an x. Let's see, what about the second term? So we've got 4 over 1 times 5 over 6. 4 times 5 is 20. Keep the denominator because it's times by 1, so 20 over 6. The last one, 4 over 1 times 7 over 1 is 28. So our new equation would look like this. X minus 20 over 6 equals 28. So part A is asking, do any fractions remain? And yes, I still see a fraction in the equation, and it's 26ths. So now it says part B, if you have not already done so, decide how you can change your result from part A so that no fractions remain. Then solve the equation. So I kind of did this a different way at first, but I'm going to do it a different way. So if I want to get rid of this 20 over 6, I'm going to multiply everything by 6 because that's going to eliminate the fraction. So if I do everything by 6, 6 times x, 6 times that, 6 times that, 6 times x becomes 6x. 6 times 20 is 120. Keep the 6 on the bottom. And then 28 times 6, I think it's 168. Dad, what's 120 times 6? Wait, no. 28 times 6. 168. Am I right?
Yeah.
Yes. 168. Got it. So now this 120 divided by 6 will become 20. Whoa, it's not 20. Equals 168. And I'm running out of room, so I'm going to erase some stuff up here and finish the problem out here. Okay, so I'm going to bring that 6x up here. 6x minus 20 equals 168. Okay, I want to get x alone by itself on this side, so I need to get rid of this minus 20. I want to make it 0. To make a minus 20 0, you add a 20 to it. Have to do the same to the other side to balance it out. That becomes 0. Bring down the 6x equals 188. Divide both sides by 6. Plug that into your calculator and you will get 31.33 forever. 31 1/3. Whew, so that was part B. Now part C is making us go back and notice that when we multiplied the equation by 4, like we did here, it didn't eliminate all the fractions, so that was no-no. That did not help us out very well. Made us do more work. So for part C, it wants us to figure out what could we have multiplied this equation by to get rid of all the fractions. Because we don't want to work with fractions, they're just not as easy as whole numbers. So here's what I thought. I thought, well, I need to find a number that is a multiple of both 4 and 6, just like if I'm adding fractions and I need, say you were adding like 1/4 plus 5/6. You can't add those, right? You need to find a common denominator first in order to add the numerators. So I thought of it that way. So I'm going to erase this and rewrite the equation. X over 4 minus 5/6 equals 7. Okay. So here's how I'm going to find a common denominator. You might already know it, and if you do, you can keep going, but I'm going to show you how I figure out my least common denominator. So I'm going to find the multiples of 4. When you're finding multiples, you're just counting by that number. So let's count by 4s. 4, 8, 12, 16. I'm going to stop there. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. So I've been noticing a lowest common multiple there, or least common multiple, that they share is 12. That's going to be our magic number for this. So if we multiplied, let's see what would happen if we multiplied everything in the equation by 12. And I'm going to bring all the work down here. So it has to be multiplied to each term in the equation, 3 terms. So let's do that 12 over 1 times x over 4 first. So if I multiply across, I get 12 times x, which is 12x. 4 times 1 is 4. And I can simplify that even more, because that just means 12 divided by 4, which is 3x. Okay, so that's the first term. Second term is this one. So let's do 12 over 1 times 5/6. 12 times 5 is 60. 6 times 1 is 6. 60 divided by 6 is 10. Nice whole number. Okay, let's do term 3, which is 7. 12 over 1 times 7 over 1 is 84. So now let's put it all together back in our equation. So we start with 3x minus 10 equals 84. Much easier problem to solve because there's no fractions anymore. Okay, so now I'm going to erase this work and we're going to solve that 3x minus 10 equals 84 up here. And see if we get the same thing that we got in the last problem. Okay, to get x by itself, I need to get rid of this minus 10. To get rid of a minus 10, I add 10 to make it 0. I have to do the same to the other side to balance. I'm left with 3x equals 94. Last step, divide both sides by 3 to make it balanced. This becomes 1x 94 divided by 3 in your calculator should come out to 31.33 forever. Whew. So that was part C and a little bit of part D, but we also have to check this in our original equation. That's what it wants us to do for part D, is to check our solution. So let's see. I'm going to put it over here so we remember what it is. I'm going to erase this stuff. Let's plug it back into the original equation. So here's the original. We're going to plug that x for that x. 31.33 over 4 minus 5/6 equals 7. And I just put this in my calculator. So I put this in first, divided it by 4, and I got a number. Then I minused it by 5/6, and it should come out to about 6.999 something, but it works. It is the solution. X is 31 1/3. Okay. 765. Is it still recording? Yes, it is. 765 gives us another equation to work with. And it says, oh, it's naming what this strategy is called. So this method that we're using to get rid of the fractions is called fraction busters, because multiplying the equation by a common denominator busts or eliminates the fractions. So the result is an equation with no fractions. So now Sherry, or Cherry, whatever her name is attempting to solve the equation below. 2b over 3 minus a 6th equals b over 2. So this one looks a little bit different because I'm noticing each term has a fraction and each denominator is different. Also, there's 2 b's in there. So let's see, it says part A, what is a common denominator for these fractions? You might know it already, but if you don't, I'm going to show you what I would do to figure that out. So if you were adding all these fractions together, you'd have to find a common denominator. So I'm going to find the least common multiple of each. 2, 4, 6, 8, 10, 3, 6, 9, 12, 15, 6, 12, 18. So I already see one. The number that is the least that they all share is 6. So that is what we are going to use as our common denominator. And we use it to multiply to everything inside the equation. So we're going to do that for part B. We are going to multiply 6, and actually, yeah, I'm going to write it here. 2b over 3 minus 1/6 equals b over 2. Okay, let's use our least common multiple. Multiply everything in the equation by 6. I'm left with, and I'm not going to work out all of the work this time, I'm just going to kind of, just for the sake of time. 6 times 2 is 12, keep the b, over 3. 6 times 1 is 6 over 6. 6 times b is 6b, keep the 2. Now I can eliminate, or not eliminate, well yeah, simplify these fractions. So 12 divided by 3 gives us 4, keep the b, minus 6 divided by 6 is 1. 6b divided by 2, 3b. Now I'm ready to solve it because it doesn't have any more fractions, which makes it nice. 4b minus 1 equals 3b. Okay, let's see. I'm going to I'm going to minus a 4b from both sides. There's a couple ways you could do this. I'm taking this way. All right, so 4b minus 4b is 0. Now we're left with negative 1 equals 3b minus a 4b is a negative b. Now if you think to yourself, well, what does b have to equal to become a negative 1? B has to be 1. Now it says check your answer. So let's plug that back into the original equation, which was 2b over 3 minus 1/6 equals b over 2. Okay, plug in that one for b. Let's go. 2 times 1 is 2, because I'm just plugging in that 1 right there, minus a 6 equals 1/2. Well, let's see, does 2/3 minus a 6 equal 1/2? You can either solve it or, I mean, we can do common denominators again. If we multiply that by 2, multiply that by 2, multiply that by 3, multiply that by 3, you get 4/6 minus 1/6 equals 3/6. And that looks correct. So B is 1, and we checked our solution. Okay, I think there's 3 more problems. This is kind of a long lesson today. And it's hot. Okay. 766. We get another equation. Sherry is worried that Sweetie is too thin. 9.5 pound cat. You think that's thin? You think 9.5 pound cat is thin? No? Yes? Dad, do you think a 9.5 pound cat is thin? Whoa! So the doctor tells Sherry the weight of a typical cat like Sweetie is given by the W in this equation. So a healthy cat is within 2 pounds of the typical weight. So let's see what the typical weight would be. Here's the equation. It's got some fractions in there. So it wants us to solve for W. Once we solve for W, we will know if Sweetie is too thin. Okay, so I'm looking at my equation. I've got fractions. I want to get rid of the fractions with fraction busters. So what I'm going to do is I'm going to find the least common multiple here. And I'm going to kind of skip through this part because we should know by now that the least common multiple between 5 and 10 is going to be 10. 5 times 2 is 10, 10 times 1 is 10. So we don't have to do all that work. So let's multiply everything by 10, we'll see what happens. So 10 times 3 is 30 W over 10 plus 10 times W is just 10 W over 5 equals 10 times 5.5 is 550. Just moving that decimal over to the right once. Okay, let me just make sure I'm at the right spot. No. Why did I say 550? Why didn't anybody correct me? I moved the decimal over once, not twice. Jeez. Okay. 30 divided by 10 is 3. Keep the W. 10 divided by 5 is 2. Keep the W. Equals 55. 3W plus 2W is what? Dad, what's 3W plus 2W?
5W.
Thank you. It's just weird. I don't have anybody to talk to anymore during the lesson. 5W equals 55. Divide both sides by 5. W equals 11. So that means that's the typical weight is the cat within 2 pounds of the 11 pound typical weight. Yes, because Sweetie is 9.5 pounds. So we've got a range of 9 to 13 pounds, and yep, she fits inside the range. So Sweetie is a healthy little baby. You see, Sweetie. I know Doe weighed a lot more than that at one point in his life. Okay, 767. This is a long one. Okay, we've got, you know what? I'm only going to do one of these. I'm going to do one, but you need to do all 3. So I'm going to do the first one for the sake of time and to show you how I would solve it. And then you guys are gonna try B and C on your own. All right, so let's do A. 5x over 6 plus 11 fourths equals 17 thirds. All right, so we've got fractions here and we need to bust them out. So we need to find a common denominator for all of them. So if I make my little lists, count by threes, 3, 6, 9, 12, 4, 8, 12, 16, 6, 12, 18, and I see one already, it's the 12. So that 12 is going to be our magic number here. Move this A over here. So if I multiply everything in the equation by 12, let's do that. 12 times 5 is 60. Keep the x over 6. Plus 12 times 11 is 132 divided by 4, because you keep the 4 on the bottom. 12 times 17 is 204 divided by 3. Whoa, yes, that's right. Okay, 60 divided by 6 is 10x plus 132 divided by 4 is 33. 204 divided by 3 is 68. Okay, now it's a nice, simpler equation with integers. Minus that 33 from both sides. Left with 10x equals, what is that, 35? Divide both sides by 10. X is 3.5. Okay, so that was part A of 767. You're gonna do B and C on your own. So same strategy, we're busting out the fractions by finding a common denominator. Okay, so that's part A, but you're doing B and C. Okay, I'll do 768. I'll do 768A, but you guys are gonna do B too. This one's 300x minus 1500 equals 2400. So now it's asking, use fraction busters in reverse. Use fraction busters in reverse to rewrite these equations with smaller integer coefficients. So here's our coefficients, our integer coefficients. Oops. So we want these to be smaller integers. So I can actually divide, instead of multiply, the opposite of multiply is divide the entire equation by 100. If I do that, 300 divided by 100 gives us 3. Keep the x. 1500 divided by 100 leaves us with just 15. 24 divided by 100 gives us 24. So now it's a bit easier to work with. If I want to solve for x, get rid of the minus 15 by adding a 15 to both sides. I'm left with 3x equals 39. Divide both sides by 3. 39 divided by 3 is 13. So x would be 13. So that is the fraction busters in reverse. So you can manipulate equations to make them easier to solve, which we've been doing this whole time. And you can do them, you can either multiply everything by the same number, divide everything by the same number, as long as you're consistent across the entire equation. Whew, that was quite the lesson. All right, I will see you in the next lesson. Bye-bye.